So in this problem, we need to verify that sine 2 theta divided by 1 minus cosine 2 theta equals cotangent of theta. We will begin from the left hand side. So here on the left hand side, we have sine 2 theta divided by 1 minus cosine 2 theta. Now we can expand sine 2 theta because there's a trigonometric ratio of multiple angles. We have sine 2 theta given by 2 times sine of angle theta times cosine of angle theta. And cosine of 2 theta can be expressed as cosine squared theta minus sine squared theta. We also have one form which is 1 minus 2 times sine squared theta, and a third form given by 2 times cosine squared theta minus 1. Now let's come to the numerator. The numerator will be 2 times sine theta times cosine theta. However, we have to be a little careful while choosing the value out of the 3 for the cosine theta, cosine 2 theta. We'll have to choose cosine 2 theta in such a way that the 2 terms in the denominator reduces to a single term. The only way to do is by getting rid of the value 1 here, the term 1. So let's do one thing. We have 1 minus cosine 2 theta. So if we replace cosine 2 theta with 1 minus 2 sine squared theta, we have 1 minus 2 sine squared theta, then this is going to help us get rid of the 1 in the denominator. So we have 2 times sine theta multiplied to cosine theta, and we will be left with 2 times sine squared theta in the denominator. Now we can factor out 2 from the numerator and the denominator. 1 sine theta also gets factored out. That leaves us with cosine theta over sine theta, and this ratio is nothing but the cotangent function. So we have cotangent of theta, which is the expression on the right hand side, hence proved.